Hey guys! Alright, so we're on to the second part of this unit. We're going to be talking about theoretical versus experimental probability. We're going to be focusing mostly on theoretical and talking a little bit about experimental. Experimental we'll talk about tomorrow as long as some of this theoretical probability things. Alright, so probability is the chance of something happening. It is always a number between 0 and 1, or you can think about it from 0% to 100%. It will never be over that, okay? An outcome is something that can happen. A sample space is all the outcomes. It's a set of all the outcomes. That's what I should write. So the set of all the outcomes. And an event is either a subset. It is a subset, or sum of or some outcomes. It's a few, one to a few, of the sample space. So the way you find the theoretical probability is you find the number of possible outcomes that you want, or the event, the probability of the event, or the number of events that you want to have happen out of the total number of outcomes in the sample space. Okay? We're going to practice this a ton, so much. All right, so right here we've got a jar containing 50 red marbles, 20 white marbles, and 30 blue marbles. You need to pick a marble from a jar at random. So you shake it up and then you're picking out a marble. What's the theoretical probability for each? So first off, how many marbles are in this jar? There's a total of 100 marbles. All right, so what's the probability of red? So red, there are 50. So that would be 50 out of 100 marbles, which is going to be 50%. Or you can think about this as 1/2. What's the probability of blue? So there are 30 out of the total 100 marbles are blue. So then we would do, that is 30%. Or you can think about it as 3/10 if you really want. Okay, the probability that something is not white. So that would mean that I figure out how many are white. So there are 20 out of the total 100 that are white. Well, there are 100 in total, so 100 minus 20 should be how many are not white. So this is 80 out of 100, which is 80% are not white. Now, the probability of red or blue implies that we don't care if as long as it's red or blue. So the number of red would be 50 plus the number of blue, which is 30 out of 100, equals 80 out of 100, which is 80%. All right, hopefully you guys caught on to that. That wasn't too bad. All right, I've got to talk about a word. It's called the complement. It's what happened here. This is a complement. Okay? You basically take the sample space, so all the probabilities, minus the probability of the event will equal the complement. Okay? Or you can think about this as 100% minus the probability of the event as a percentage, and that'll give you the outcome. And this is called the complement, so it's probability of event, and then usually it's like a little c. Okay, that's all it means. All right, moving on. So each of the numbers 1 through 10 are written on a card and placed in a bag. The bag is shaken up, and one card is drawn at random. What's the sample space? So what are the possible outcomes that I could have? Well, we could draw out a card with 1 on it, or 2, or 3, or 4. If you haven't gotten the hang of this yet, we're just writing all the numbers of 1 through 10. So that's the sample space. Now it says, what is the event of drawing an odd number? So this would just be a subset of all the odd numbers. So 1, 3, 5, 7, 9. This is the event of drawing an odd number, 1, 3, 5, 7, or 9. What's the probability of drawing a card less than 5? So let's first off find the event of drawing a card less than 5. So that would be 1, 2, 3, or 4. Anything bigger than that is 5 or greater. So that's a total of 4 out of 10, which is 40%. That's the probability. Now it says, what are the odds of getting a number less than 5? Well, that would be 4 to 6, right? Because there are 4 numbers less than 5 and 6. If you wanted to reduce that, you could. And it would be a 2 to 5 odds. Because 4 are less than 5 and 6 are not. Does that make sense? That's what the odds are. All right. Scrolling on down. Working our way down the page. Okay, there are 30 students in study hall. This table shows the number of students who are studying a foreign language. What is the probability that a randomly selected student is not studying a foreign language? So the first thing to do is figure out how many are studying a foreign language. So there's a total of 30 students in the hallway. So that would be out of 30. So we do 14 plus 8 plus 5, and we get 27. So that would be 27 out of 30, which happens to be 9/10. So 90% are studying the foreign language. So if we took 100% and minus the 90%, we get 10%. So 10% chance of pulling a student at random that's not studying a foreign language. All right, so in a class of 150 students, 95 are taking math, 76 are taking science, and 53 are taking both math and science. So they filled out this beautiful Venn diagram. That means 53 are taking both, 42 are only taking math, 23 are only taking science, and 32 are taking neither. Does that make sense? That's what that's talking about. All right. So the probability of not taking math. So if 95 students are taking math, all you have to do is take our total of 150 minus 95. We're going to divide that by the total 150. So we pull out our handy-dandy calculator. We do 150 minus 95. We get 55 over 150, which is approximately, let's find out what percentage that is, 36.7%. Cool. All right, what's the probability of taking neither math nor science? So this would be the 32. So we've got 32 that are taking neither. So you do 32 out of 150, and that's going to give us a percentage. So 32 out of 150, and that's 21.3%. Cool. All right, taking math, but not taking science. So that would be only these 42 students. So that would be 42 out of 150, and that'll be approximately, so 42 out of 150, and that's approximately, well, actually, that's exactly 28%. Perfect. All right, how you guys feeling? We're just going to do the stuff on permutation, and then we're going to call it good. All right, so for permutation, we need to remember a couple things. So we need to remember our thing. Remember, it's NPR, where R is the number we're choosing. So the students are given a 4-digit code for computer access. No digit can be repeated. Abby receives the code 1, 2, 3, 4. What's the probability that she would receive a code of consecutive numbers? Okay. So we're going to do N, which is the total of, so we've got to find the number of outcomes in the sample space. So there are a total of 10 single-digit numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are 10 single-digit numbers. So we're going to do 10, choose, and we only want to choose 4. Now I'm going to show you something on your calculator. And some of you might have already noticed it. So if you press math and you go over to prob, which is probability, and then we're going to do NPR. So my N is 10, and my R is 4. So that's 5,040. So what is the probability that she would receive a code of consecutive numbers? 0, 1, 2, 3. Then we have 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8, and 6, 7, 8, 9. Okay, and then we have to do the other way. So we would do 9, 8, 7, 6, 8, 7, 6, 5, 7, 6, 5, 4, 6, 5, 4, 3, 5, 4, 3, 2, and 4, 3, 2, 1, and 3, 2, 1, 0. There's a total of 14 outcomes of counting in order. Whew. That's frustrating. All right. So that means we have 14 out of 50, 40. If we pull out our handy dandy calculator, we do 14 out of 50, 40. And we get 0.28%. That is not very likely at all. So on this next one, 6 books are labeled A through F and arranged at random on a shelf. What is the probability that they are arranged in alphabetical order? So first, we've got our 6 books, and then we're arranging them. So that would be, so we've got 6P6. We're arranging things in the exact order, in the exact thing. So this is really just 6 times 5 times 4 times 3 times 2 times 1. That's the number of options we're going to have. And if you remember to yesterday, 2 days ago actually, it's 720, it's 6 factorial. If you want to check me, you can. I'm not going to. Okay, so how many ways are there to organize A through F in alphabetical order, assuming that they mean alphabetical order to mean from A being the first and F being the last? 1. There's exactly 1 way. So we would do 1 out of 720. So we pull out our handy dandy calculator. 1 divided by 720. And we got 0.13. So this is approximately 0.139%. Or you can think about it as 0.139%. That is a very, very tiny number. All right, that's as far as we're going to get today. I love you guys. You're doing so good.